Welcome back. So continuing on, a couple of other things I need to show you. Up here is the status bar messaging, and if there's an error message or anything like that, it will show up here. And there's a myriad of error messages showing various states of things. And then over here, this is our version. So this is a side-loaded IoT, Windows IoT Core app. And as such, normally we would host this in the Windows Store, but because this requires some hardware permissions and some communications through the USB port to the Arduino that sits on the roller itself, we're side loading and we're checking updates every single time the application runs. Now, as I mentioned before, this X here actually quits the application. On this PC, if you quit the application will just stop and you'll go back into the Visual Studio where the code is. But in this case, that's what would happen. But on the real computer, what happens is the program shuts itself off, and because it's a headed application, it's the head application, it's the run on startup application, the entire program reboots, and when it comes up, it comes back to this screen, and when it first comes back to this screen, it takes a few seconds. It's actually looking on a server that I have set up where the program, update files exist. So if I push an update, this automatically gets updated every single time they start it. So I can push updates all day long. There's danger in that. There is definitely a risk to that. But it's even more of a risk if we don't do that, because we need all the machines to be running on the same version. So I check and test everything very, very thoroughly when I first start. As an example of a real recipe, for example, like Beyond Plus Multi, we've got this White Source 6Y20. This is actually a production run. So the first speed will have the first speed, second speed goes to like 280 or something like that. But for this demo, we're going to go ahead and we're just going to use our live with our Ben demo. Ben is the B in BD Dental, and it was to show him. So down here is a timeline that shows the speed history recorded at 1 second intervals. So we can actually detect if the actual speed at a given time. So I'm going to go ahead and start this to demonstrate it. We're going to go with live and demo, and we're just going to hit the power button and turn this baby on. This will detect what the current speed is supposed to be, and it will simulate that speed within 3 or 4. There's a random I'm simulating the actual motion detector, so there's some randomness to it. So you'll actually see the current RPM fluctuate quite extensively. Let's go ahead and start it. So I push the start button. Our current speed is shown this green area. You'll notice there is some fluctuation up here. That's simulated fluctuation. That's every second, and that is just to simulate, the real life thing. Like if there's a little tiny bit of drag or whatever, or maybe it slows down, it needs to overcome it. It controls it through this throttle. Now the throttle is static. I've got it set to 15. For simulated purposes, I probably should add a little bit of randomness to this as well, but I haven't. It's just 15 now. So this is the total elapsed. This is the amount of time step elapsed. Of course, those are equal because we're in the first step, and here's the remaining for that step. So in a second here, this will change to 2. This will continue counting up to 1 minute over. This will start over again, and this one will start over on the end of the remaining step, and then this total remaining will, of course, continue counting down. So here's step 2. Our target speed is 340. Our RPMs, of course, are some random variant of that, and we can see that the history line has indeed changed a little bit. We can actually pause the step. So if we pause this, now we're in pause mode. Pause mode stops the clocks and stops the time. So this gives them a chance, say, they've just barely started a step and they want to add some bottles, or they want to pull a bottle off for some reason. They need to, maybe the load is too much or whatever. They can actually pause it. So in this state, I just hit the power button again and it simply resumes where it was at. Everything starts counting down again. Again, the next speed is this speed, the current speed, and step 2. This heart represents a heartbeat. So this heartbeat reports to Azure over the internet through a MVC web API, and basically it's updating a record in the database that says, yes, am I running? When did I start? What is my current target speed? What is my current actual speed? And what step I'm on. That data is looked at once every 5 minutes by an Azure function, which is a function that runs without a computer. It's a very, very cheap way to get functionality into Azure and make it run as a virtual computer. This second needle over here is the bottle speed. As you can see, it's somewhat lower than the roller speed. That's because the bottle is larger. So this is spinning faster while this is slower. This here is a report of it's a literal heartbeat to show what we're doing. Down here, the timeline continues. We have time matrix on the bottom. We show it. It's very much like a spark line for an investment thing or whatever. And then, so anyway, that's the functionality, and that's kind of how it works. I will provide a link to the source code so that you can do a poll if you would like to see what I actually wrote. Meanwhile, have a great one.